Another common application of basic differential equations is Newton's law of cooling. So Newton's law of cooling states that the rate at which an object cools is proportional to the difference between its temperature and the ambient temperature. Okay, so let's denote the temperature of the cooling object by U of t, and then we will denote the ambient temperature by A. So for room temperature, this might be 72 degrees, something like that in Fahrenheit. So pause the video for a moment and figure out what the differential equation should be that encodes this sentence here based on what we did in the last video. So pause the video for a moment and see if you can formulate that differential equation. Okay, so it would look something like this. So we would have the time rate of change of the temperature of the object, and then is proportional to means is a constant times, and then the difference between the temperature and of the object and the ambient temperature would be U minus A. Now, there's a little bit of ambiguity here because we don't know if this should be plus or minus in front of the temperature right here. So pause the video for a moment and think about whether or not this constant K should be a positive number or a negative number. Okay, so I hope you came to the conclusion that, in fact, if K is going to be a positive number, we need to have a minus sign right here. So, in other words, if the temperature of the object is greater than the ambient temperature, then that means that U minus A is going to be positive. So, however, in the case when U minus A is positive, that means that we need the temperature of the object to be decreasing, so the derivative should be negative. So by putting in a minus K out front, we're ensured that the temperature of the object is going to be decreasing. So this is the standard form for Newton's law of cooling as an ordinary differential equation. Okay, so we will see when we learn how to solve these things that U looks like A plus some initial temperature times e to the minus kt. And so the solution curves for such a system look like this. Let's see if we take our ambient temperature here to be in blue, then we're just going to have some exponential curves. So this is something warming up to room temperature that you've just taken out of the freezer. And then here's something cooling down to room temperature that you've just pulled out of a hot oven. Depending on whatever the initial temperature is that you choose, these values right here.